Alright, let's look at the homework 8.2, problem number 3. Alright, so let's set up the integral here. As usual, s is going to be equal to 2 pi. And then it's going from, integral goes from 1 to 3, so that's easy. And the radius is going to be just a function value since it's rotated about the x-axis. 1 plus 3x, right? Then we just have to do the arc length formula, so let's do that. First we have to find the derivative, so dy over dx is going to be equal to, square root is 1/2 power, so we put 1/2 in front, and 1 plus 3x, and subtract 1 from the power, so it's a negative 1/2. Then multiply by derivative inside, which is going to be 3. Alright, so if you rewrite that, it's going to be 3 on top, then 2 on the bottom, then you have a square root of 1 plus 3x on the bottom. Alright, so it's going to be 1 plus that guy's square, so dy over dx squared, so 3 squared would be 9, and over, and the 2 squared is 4, and you have a 1 plus 3x. Right? Then we have dx. Alright, so let's simplify that. So this is going to be 2 pi integral from 1 to 3. I'm going to leave this guy as it is for now. 1 plus 3x here. Right here, I'm going to take the common denominator. Alright, so it looks like we're going to have 4. Alright, then you have a 1 plus 3x. Right, so 1's going to be 4 plus 12x. Right, and then plus 9. Right. Alright, actually, can I combine, let's see, 9 and the 4 together? So that's going to be just simply 9 plus 4, 13. Right? Then you can see that here, we can actually cancel square root of 1 plus 3x on top and the square root of 1 plus 3x. So we can cancel this guy with that guy. Right? So we have a dx. Right? So we have, let's see, I'm going to clean this up a little bit. Alright, so it looks like we're going to have simply 2 pi integral from 1 to 3. Alright, square root of 4 is 2, so 2 on the bottom. And then you have a square root of 12x plus 13. Right? So we can cancel 2 on top and a 2 on the bottom. And I forgot to put the dx there. Alright, so if you want, we can use a substitution. Let u be 12x plus 13. Right? Then take the derivative of u with respect to x, that's going to be 12. And then take the reciprocal of both sides, dx over du is equal to 1 over 12. And then multiply by du. Right? So we have dx is equal to du over 12. Right? Then also, since x is going from 1 to 3, u is going to go from, plugging 1, 12 plus 13 is 25, to plugging 3, so 36 is going to be 36 plus 13, so it's going to be 49. Alright, so this is going to be pi integral from 25 to 49, right? And we decided to call this guy u. So it's going to be square root of u. So I'm going to write it as u to the 1/2 power with respect to x. Oh, actually, sorry, I messed it up. And instead of with respect to x, du over 12. Right? So let's put the pi over 12 outside. Find the antiderivative of u to the 1/2 power. So add 1 to the power. Divide by 3/2 is multiplied by 2/3. Right? Then you're going from 25 to 49. Right? So we can cancel 2 and the 12. So you get 6. And to combine that, you're going to get the pi. And 3 times 6 is 18. So we already took care of this guy and then that guy. So we just have to plug in 49. So 49 square root of 49 is 7. And then you have a 7 cubed. So 7 cubed minus, plug in 25. So it's a 5 cubed. Right, what's 7 cubed? So 7 times 7 is 49 times 7. 63 and 28, so it's going to be 34, right? And you are subtracting, let's see, 25 times 5 is 25 and 125. So subtract 125. Alright, so that's 8, 1, and 2, let's see, yeah, 2, 18. Alright, so this is going to be 218 pi over 18. Actually, you can divide through by 2, so that'll be 109, and it's going to be 9, right? And I think that's about it, right? So this is 109 pi over 9. Alright, so let's type it in. We got the 109 pi over 9. Alright, submit for testing. Alright, I came back and looks like we got this one correctly as well. Alright, that's it. I hope that this was clear.